Yes, my intention is to give a short lecture with this title. Gustav Elfving's research activity was characterized by a broad spectrum of interests. His contributions to the development of the optimal design theory, which are of interest in this workshop, were published mainly in the 1950s. During that decade, I graduated and started my postgraduate studies. As a student of Elfving, I had the opportunity to follow this part of his scientific activity. In the following, I shall give some comments on his research and my personal valuation of their significance for the general development of this part of the statistical theory. To everybody familiar with the present status of the optimal design theory, his mathematical style seems to be somewhat out of date. However, a careful reading of his papers shows that many problems, which are still of general interest, emanate from, or at least can be found in his articles. And here is a list of the main papers. In the following, I do not intend to give an exhaustive presentation of these papers. In the history of optimal design theory, Elfving's paper, Optimum Allocation in Linear Regression Theory, is probably one of the most central contributions. After almost 4 decades, it is still frequently cited. In this paper, he studied C-optimal and A-optimal designs long before these concepts were coined. Also, he considered the problems only in 2 dimensions and assumed non-singularity and differentiability. He obtained elegant results and gave strong stimulus to succeeding research. Within his framework, he gave the first optimality criterion according to which one can decide if an observation is relevant or not. And let us look at his geometric figure. This is taken from his paper. This is the classical figure, which indicates that only observations whose coefficient vectors lie on the convex hull can be relevant for the C-optimal design. And as all of us knows, if we intend to estimate A prime beta, yes, the coefficient vector A, we have to concentrate us on the observations x1 and x2. Later in the papers, Convex Sets in Statistics and in a unified approach to the allocation problem in sampling theory, Elfving made use of this convexity argument in more general frameworks. In these last mentioned papers are also given the maximal number or different observations contained in the optimal CA and AS designs. These maximal numbers go back to an earlier result given by Chernoff in '53. In my thesis, I was able to prove that the convexity argument holds for rather general design criteria. These ideas, proposed by Elfving, started the sequence of research concerning design theory. The papers by Kiefer and Wolfowitz place play a central role in the development of this part of the theory. Generalizations of Elfving's results in order to drop the assumptions of non-singularity and of differentiability can later be seen in a lot of papers, e.g. Kahlen, Studden, Fellman, Silvi, Gafke, Pukelsheim and Tittering. In this connection, we shall not forget the monographs by Fedorov and Silvi. A more general presentation was given by Elfving himself in the paper Geometric Allocation Theory. According to my opinion, Elfving's successors have not paid enough attention to this paper. Here, Elfving combines experiments in a more general way by allocating sets of correlated observations. He also considered the singularity and he eliminates it by a transformation of the parameter vector. After this transformation, there remains a smaller set of estimable parameters. According to my opinion, such a transformation is no general solution in optimal design theory. The optimality criterion can and often will be ill-behaved in the optimal point. Furthermore, the singularity, that is a set of estimable parametric functionals, may vary over a set of designs. Under such circumstances, a common transformation for the whole set of designs cannot be found. My opinion is supported by the fact that the problems connected with singularity have occupied so many of Elfving's successors. The other papers by Elfving are less general. In selection of non-repeatable observations for estimation and in a selection problem in experimental design, Elfving considers the design when the observations are non-repeatable. The main result is that the solution of this design problem is a hyperplane condition quite similar to the well-known condition obtained for the standard C design. In minimax character of balanced experimental designs, Elfving considers the estimation of main parameter contrasts in incomplete block designs. His result is that balancedness is the necessary and sufficient condition for the incomplete block design to be a minimax design. I conclude my short review of Elfving's contributions with his own review. In the paper Design of Linear Experiments, in the Harald Kramer volume, Elfving gives a short but well-written and comprehensive synthesis of his own contributions. I can warmly recommend this paper for everybody who today intend to make acquaintance with Elfving's investigations. In his studies, Elfving was primarily interested in new and basic ideas. He was less interested in attempts to obtain the utmost generality. The generalizations were left to his successors. Therefore, he was able to carry through his studies with a minimum of mathematical sophistication. Often ordinary calculus and basic matrix algebra were enough. Therefore, the central ideas in his papers are not obscured by overwhelming outworks of mathematical technicalities. This fact, in connection with his personal talent for writing a lucid text, makes his papers elegant and highly readable. Thank you.
Thank you. I just like to comment that I was a student at Columbia in 1947. Elfving visited Cornell, I think it was said 49 or 50, and I remember that Elfving gave a talk on optimal design, on some of these ideas. And it's not clear to me that he didn't have some of the results. You know, there's the Chernoff paper and there's the Elfving paper. There's a certain overlap. But it seems to me he did have some of those results in 1950. But I can't remember that well. But anyhow, thank you for clarifying that.